this lesson, we will discuss the basics of probabilities with cards. First, we need to remember a few rules and definitions. The first one is the definition of an event. An event is a collection of outcomes. A simple event is an event that cannot be broken down further. A sample space are all the possible simple events. P denotes the probability, while A, B, and C denote specific events. The probability of A is the probability that event A occurs, as given in the formula. The probability of event A equals the number of times event A occurs over the total possible outcomes. The complement of an event, denoted by an A with a bar over top, which means not A, or all of the events that do not include A. The probability that A does not occur is given by the symbol P of not A. If the probability that A occurs is 0.4, then the complement or probability that A does not occur is 0.6. For example, if the probability that it'll rain tomorrow is 0.1, then the probability it will not rain is 0.9. Here are some basic probability rules. First, the probability of an impossible event is 0. For example, in a single roll of a 6-sided die, the probability of getting an 8 is 0, since there is not an 8 on a 6-sided die. Second, the probability an event is certain to occur is 1, or 100%. For example, the probability that nitrogen is in the atmosphere tomorrow is 1. Actually, our atmosphere is approximately 78% nitrogen and only about 21% oxygen. Now, for any event A, all of the probabilities are between 0 and 1 inclusive. This means that no probability is greater than 1 or less than 0. In other words, you cannot have a negative probability. Next, the sum of all the probabilities in an experiment equals 1. This is why we intuitively know that if the probability it's cloudy tomorrow is 0.3, the probability it's not cloudy is 0.7. It's because the probabilities must add to 1. Now, let's take a standard deck containing 52 cards. Each deck of cards has 4 suits: hearts, diamonds, clubs, and spades. In each suit, you have 13 cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Since there are 4 suits, the probability of getting a heart is 1/4. The probability of getting a diamond is 1/4, and so on. So if the event A is getting a spade in a standard deck, then the probability of A equals the probability of getting a spade, which equals the number of spades divided by the number of cards in the deck, or 13 out of 52, which is 1/4. The complement would be the probability of not getting a spade, which is the number of cards that are not spades: diamonds, hearts, and clubs, which is 39 out of 52, or 3/4. Now let's consider aces in the deck. There are as many aces as there are kings, queens, or jacks. The probability of getting an ace is the number of aces in the deck divided by the total number of cards in the deck, or 4 out of 52, which is 1 out of 13. Now, what is the probability you have a king or a jack? The OR rule says the probability of A or B equals the probability of A plus the probability of B if mutually exclusive, which means there are no elements in common. If there are elements in common, then the OR rule says that the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So you ask yourself, are there any kings that are jacks? No. Then kings and jacks are mutually exclusive, so that the probability of a king or a jack equals the probability of getting a king plus the probability of getting a jack, which is 4 out of 52 plus 4 out of 52, which is 8 out of 52, and that reduces to 2 out of 13. Now, what is the probability of getting an ace or a spade? Notice in this case there is a card that is both an ace and a spade. So the probability of an ace or a spade equals the probability of an ace plus the probability of spade, minus the probability of the ace of spades, which was counted twice. And you cannot count any card twice. Okay, now, what is the probability of dealing 2 aces in a row? This requires the AND rule. The probability of A and B equals the probability of A times the probability of B given A. So the probability of getting an ace and then another ace is equal to the probability of getting an ace times the probability of getting an ace given that the first ace is no longer in the deck. This gives you 4 out of 52 times 3 out of 51. Notice in the second factor, there are only 3 aces left in the deck and only 51 cards, which you have to take into account in the AND rule. Before you play a game of blackjack, you should probably know one more key piece of information. Blackjack is sometimes called 21 because you want to get as close to 21 as you can. But whatever you get, you want it to be higher than the dealer, but you cannot go over 21. If you go over 21, you lose. So you really need to know your probabilities. To get a blackjack, you need a 10 card and an ace, which counts as 1 or 11. The 10 cards are 10, Jack, Queen, and King. There are 4 of each. So there are 16 10 cards in the deck. Therefore, the probability of the 10 card, 10, Jack, Queen, or King, equals 16 out of 52, or that reduces to 4 out of 13. The calculation of the probability of blackjack is a bit tricky, but the probability that the first 2 cards are a blackjack equals the probability that you get a 10 card and then an ace, plus the probability of an ace and then a 10 card. You can see we have to combine the AND rule for the ace and the 10 card and the OR rule because we could get the ace first and then the 10 or the 10 and then the ace. This gives you 16 out of 52 times 4 out of 51 plus 4 out of 52 times 16 out of 51, which equals 128 over 2,652, or 0.0483, which is a 4.8% chance. I will have to create another video to go in more detail, but for now, let's play blackjack.